Dear students, in the last class, I think we have discussed the fundamental Neyman Pearson lemma. I think you got some idea about the fundamental lemma in the last class. This was the lemma we have discussed, and I think we have already discussed one problem. Okay. In that problem we have obtained type 1 error and type 2 error, etc. Now today we will discuss one more example. So let us consider this example. Let x follows binomial 2 comma theta. We want to test h0 theta equal to 1 by 2 against h1 theta equal to 3 by 4. Okay. Then what is the null hypothesis? Null hypothesis is theta equal to 1 by 2. And what is alternative hypothesis? Theta equal to 3 by 4. Now let us compute the ratios like this. F of 0, we are considering only the possible values of binomial random variable are 0, 1 and 2. Okay, because it is given that binomial x follows binomial 2 comma theta. So 0 comma theta 3 by 4 divided by f of 0 comma theta 1 by 2. So what will be the answer? Here we will have 2c0 3 by 4 raised to 0 into 1 minus 3 by 4 raised to 3. Okay. I think you know the binomial density. You know the binomial density. What is binomial density? Probability of x equal to small x equal to n. Sorry. What is the binomial density? N. C. P raised to x, p raised to x, then 1 minus p raised to n minus x, right? N minus x, comma, what are the possible values of x? X equal to 0, comma, 1, comma, 2. Okay. So this is the possible value of binomial distribution. So here they are using the notation f, but I think you have studied the notation in terms of p of x equal x. Anyway, okay, whatever be the notation, we can study the concept. So f of 0 comma theta raised theta 3 by 4. What will be the answer? What will be the answer? Now instead of n we can use 2c0, p is 3 by 4, that means 0.75 raised to 0 we can use the notation 3 by 4. 3 by 4 raised to x. Here we can use 3 by 4 raised to 2 minus 0. Okay, so that will be equal to, what is the value? That will be equal to 260 is 1, 3 raised to 4 raised to 0, that is 1 minus 3 by 4, it is 4 raised to 2. Raised to 2. That means 1 by 4 raised to 2. That means 1 by 4 by 1 by 4 1 by 4. Right. So this is the 0 value. Now what is the f of 0 comma 1 by 2? When p equal to 3 by 4. Okay. What happens when p is equal to 1 by 2? P equal to 1 by 2, what will be the result? It will be replaced by 1 by 2. It will be replaced by 1 by 2. So that is actually 1 by 2 by 4. Okay. 1 by 4. Now, what is the fraction value? Then what will be the fraction? F of 0 3 by 4 by f equal to 1 by, that equal to 1 by 16 divided by 1 by 4, that is 1 by 4. Okay, 1 by 16 by 1 by 4 equal to 1 by 4. So we can this will be, what will be the result? 1 by 16 by 1 by 4. One by 16 divided by 1 by 4, that is exactly equal to 1 by 4. Okay, so this one, that is the value given here. Similarly, when x equal to 1, we can modify modify these equations. So what happens when x equal to 1? What will be the values when x equal to 1? When x equal to 1, it will be 1. It will be 1. So this is 2 into 1 by 4 into 3 by 4. So that is 2 into 3 by 16, right? 2 2 into 3 by 4 into this one is 1 by 4. So 2 into 3 divided by 60. So what is the value? This one. Into 1 by 2 into 1 by 2, that means 1 by 2. So what will be the ratio value? What will be the ratio value? Yeah, this one is 3 into 4 by this is 2. So what happens? 1 by 2, 8, 1 by 3 by 2. I think it is 3 by 2. 3 by 4. This 4 will go above. 8 will come there. Yeah, it is 1 by 4. Right. No, 1 by 2. 1 minute. This is 2. 2 is there. 3 by 4. Then 1 minus 3 by 4, that is 1 by 4. So 2 into 3 into 2. 2 into 3 divided by 4 into 4, that is 16. This is 2 into 1 by 2 into this is 1 by 2, that is 1 by 2. 3 into 4. 3 into 4. This is equivalent to 3 into 4 into 2 by 16. This is 3 by 2. 3 into 4 by 16. Yeah, it is 2 actually. Yeah, that is the reason. That is the reason. Yeah, we will get this as 4. This is 2 only. Sorry. So 3 by 4. Okay. Right. Yeah, that is the value given here. 3 by 4. And another the next set is the next set of values. We can compute for x equal to 2. Okay. So what is the value of this? Is 1, 3 by 4. That means 9 by 16. Okay. This is okay, 1 by 4. So what will be the value? 9 by 16 divided by 1 by 4. That means 9 by 4. 9 by 4. Yeah, it is 9 by 4. So we obtained the 3 ratio values. Okay. Now let us what is the criteria? What is the criteria of this Neyman, Pearson, Lemma? F1 of, we reject if f1 of x greater than k into f0 of x. Okay. So choose k in between. So this is the lowest value, 1 by 4. This is the middle value. This is the greatest. So if we choose 3 by 4 less than k less than 9 by 4, then okay, 3 by 4 less than k less than 9 by 4, then this will be greater than k. That means 9 by 4 greater than k. So this is the case only. That means for the rejection region we have to take x equal to 2 only. So 9 by 4 greater than k means f1 by f0 greater than k. Okay, if we select k in such a way that 3 by 4 less than x less than 9 by 4, then f1 by f naught equal to 9 by 4 greater than k. That is possible only when x equal to 2. So the rejection regions taken is x equal to 2. Okay, so after identification of this rejection region, we can compute the probability of type 1 error, probability of type 2 error, and its power. Okay, so what is probability of type 1 error? That is alpha equal to rejecting h naught when h naught is true. Rejecting h naught means x equal to 2. Okay, if we select k in this region, we have to reject only when x equal to 2. When x equal to 2, this value greater than k. Okay, so alpha is equal to probability of type 1 error, that is probability of x equal to 2 given theta equal to 1 by 2. So that is I think we have computed that. Okay, what does that result? X equal to 2, that is 1 by 4. Okay, so that is 1 by 4. Now we select an alternative case, that is if k lies between 1 by 4 and 3 by 4, then simultaneously 9 and 3 by 4 are greater than k, because 9 by 4 comes after 3 by 4. Okay, so what are the possible values in the rejection region? X equal to 2 and x equal to 1 are in the rejection region. So what will be the criteria? We reject h naught if x equal to 1 or 2. So what will be the probability of type 1 error? Alpha equal to probability of x equal to 1 or 2 given null hypothesis true, that is theta equal to 1 by 2. So that is I think we have computed that 1 and 2. In the case of 1 it is 1 by 2. In the case of 2 that is 1 by 4. So 1 by 2 plus 1 by 4 means 3 by 4. Okay, so that is 3 by 4 is computed here. Okay, we added two probabilities. One is probability of x equal to 1 when theta equal to 1 by 2, and one other is probability of x equal to 2 when theta equal to 1 by 2. So that is the sum is 3 by 4. Now another case is if we select k before 1 by 4. So you know that 9 by 4, 3 by 4 and 1 by 4 comes after k if we choose like this. So these 3 points, that is x equal to 0 and x equal to 1 and x equal to 2 belongs to the rejection region. Okay, so what will be the alpha value? Since we have only 3 possible values, then the total probability will be 1. So alpha equal to 1. Okay, probability of x equal to 0 plus probability of x equal to 1 plus probability of x equal to 2 under null hypothesis true. Okay, so that is the probability of type 1 error. So okay, in this book, what is so I think you got the idea of that problem. Now note that if k equal to 3 by 4, that means k equal to 3 by 4, k is equal to 3 by 4 is taken. So we must reject when x equal to 2. We have discussed that. That means we have to accept for h naught for x equal to 0, because k is equal to 3 by 4. K is equal to 3 by 4. We are selecting k equal to 3 by 4 because we are accepting only when f1 by f naught less than k. Here, look here, when we accept only when it is less than k, we reject only when it is greater than k. So we can decide when x equal to 2 we can reject, when x equal to 1 we cannot determine, but when x equal to 0 we can determine, because when x equal to 0 this ratio value is 1 by 4, that is less than 3 by 4. Okay, so in the case of x equal to 1, that means when k is equal to 3 by 4, f1 by f0 greater than k implies x equal to 2 is the rejection region. f1 by f0 less than k implies x equal to 0 is the acceptance region. But when f1 by f0 equal to this 3 by 4, we cannot determine, it is undetermined. Okay, so this is a problem for that illustrating acceptance, rejection and undetermined decision. Okay, now there are two possibilities: either accept when x equal to 1 or reject when x equal to 1. So there are two possibilities. So what will be the probability of type 1 error when we accept for x equal to 1? When we accept for x equal to 1, what will be the probability of type 1 error? That means the values in the acceptance regions are, if we consider 0 and 1 are in the acceptance region, then what will be the rejection probability? That is 1 by 4. Okay, because we have already determined that. Now if we reject h0 for x equal to 1, so we have one more element in the rejection region, that is 1. If we accept h0 when x equal to 1, then the rejection region contains that is x equal to 2. If we decide to accept or reject h0 for x equal to 1, then one more element comes in the rejection region, that is not only 2 but also x equal to 1. So we have to add the probabilities of both cases. That means when x equal to 2 under null height, that is 1 by 4. When x equal to 1 under null height, that is 1 by 2. 1 by 2 plus 1 by 4, that equal to 3 by 4. Okay, so that value, that alpha rejection value will be alpha equal to 3 by 4. Okay, so this is a good example to understand the concept of what is that, Neyman Pearson lemma. You write and try to elaborate these steps and understand. Okay, another is uniformly most powerful normal test. Yeah, we are considering normal test. So I think it is a continuation of earlier problem. Okay, I think we have obtained the density in some problem. Continuation. Yeah. Suppose so first of all we have to find out the power function of the normal distribution. Okay. I think we have discussed the rejection and acceptance criteria in some of the previous class. And here we are considering normal power function form, that is x1 x2 x3 is a random sample taken from normal theta comma sigma square. Here mean is theta and variance is sigma square, and we are also assuming that sigma square is known. Okay, this is the what is that, hypothesis to test. So what will be the value of f1 of x by f0 of x in the case of normal distribution? Since the null hypothesis says that it is h0 theta less than or equal to theta against h1 theta greater than theta naught. So we can say that if theta is actually mean of the normal distribution, so we can take sample mean as the test statistic. Okay, and we can reject it. we can reject the null hypothesis only when x bar is greater than some c. Okay, x bar. This is the rejection region we can take, because when theta less than or equal to theta naught, this is a null hypothesis and this is the alternative hypothesis. When we have to select alternative hypothesis, if x bar, that is observed sample mean, is greater than the assumed theta naught, assumed population mean. Okay, that is the plausible criteria for rejecting this hypothesis. That is, x bar is greater than some c dash or c. X bar is greater than some c. Okay. So we can modify. We can subtract the value theta naught on both sides. Let us consider this as some d. This is some d. So x bar minus theta naught. Here is theta. Theta. We are standardizing the normal random variable. Sigma by root n. I think you know the standardization technique. So simultaneously we can subtract this same theta here also and divide with respect to, that is, we are applying same operation on both sides. Okay. Okay. This we can consider as theta naught. Okay. So this can be denoted as some c, some constant, because sigma is known, n is known, d is known, and theta naught is known. So it can be considered as some constant theta naught. Okay. So what will be the power function? This is equivalent to say that. This is equivalent to say that. What is that? move the denominator to right side. This will be now we can subtract theta on both sides. We can divide with the sigma by on both sides. So as a next step we can cancel this sigma n from here. Okay. Our critical region so this will be the okay. So this is the critical region. Now what is the power function? You know, power function is nothing but probability of the critical region under alternating hypothesis. Under null hypothesis it will become probability of type 1 error. So we can denote it as what is that, beta. Probability of power function. So it is obtained here. It is obtained here. So we can. So what will be the alpha value? Under null hypothesis, it will be the alpha value. Under alternative hypothesis, it will be the probability of. Sorry, under alternative hypothesis, it will be the power. Okay. So where is alpha? Alpha equal to under theta naught. Okay. Okay. H naught. Okay, it will be the power under H1. The function explained here, and moreover you can replace this as Z because it is standard normal. Okay, since that is standard normal, or otherwise we can put another step so that you can understand it. Z will be also Z. So this is given here. This is a probability density. Probability under the normal density. So you can see that probability of set greater than some value means probability of set greater than some value means this is the area. Okay, so that is the area. So this area will goes to suppose we consider two situations, that is mean lies between minus infinity and infinity. If theta goes to minus infinity, then what happens? If theta goes to minus infinity, then here theta minus of theta, that is minus of minus infinity, that is plus infinity. What is the value of z greater than plus infinity? What is the area after this plus infinity? It will be 0. Okay, this area will reduce to 0 as theta goes to minus infinity. This right side goes to plus infinity, so that probability of z greater than plus infinity, that means area after plus infinity, that is 0. Now what happens when theta tends to infinity, plus infinity? When theta tends to plus infinity, we can see that this is plus infinity, so minus plus infinity means minus infinity. When theta goes to when this term goes to minus infinity, z greater than minus infinity, what is that region? The ender region. That means the probability would be 1, because we are having the ender region. When theta goes to plus infinity, the term in the right side goes to minus infinity. That means z greater than minus infinity. Probability of z greater than minus infinity is probability after this minus infinity. That is area under the curve after this minus infinity. So that will be 1. Okay. So beta of theta naught equal to alpha if beta of theta naught equal to alpha. So somewhere in between minus infinity and infinity, this value becomes alpha. Okay, that alpha is beta of theta naught equal to alpha is equivalent to say that z is greater than, here we have used the z notation, z is greater than some c. Okay, z is greater than some c, because when we put theta equal to theta naught here, suppose here theta naught comes, so theta naught minus theta naught, that is 0. So that means z is greater than c, probability of z greater than c. So beta of theta naught equal to beta of theta naught equal to probability of z greater than c, probability of z greater than c. But we have already assumed that the maximum value of probability of type 1 error is alpha, that is fixed. So beta of theta naught is alpha, that means beta of theta naught is equal to probability of z greater than c, that equal to alpha. Okay, so a graph, you can see that when theta goes to minus infinity it is 0, when theta goes to plus infinity it is 1, in between that minus infinity and infinity we have some theta naught, that is equal to alpha. Okay, so this will be the shape of the, from 0 to, in minus infinity it will be 0, in plus infinity it will be 1, and in between minus infinity and plus infinity, that is a point theta naught. In that case, at the point theta naught we have beta of theta naught equal to alpha. So this will be the shape of the power function of the normal distribution. Okay, where he has stopped in the last, we were considering the Neyman Pearson lemma. At that time you have moved above. Okay, so this is another, in terms of sigma square, it is another problem. Anyway, consider this problem only, the consists of a power function in the case of normal distribution. Okay, yeah, it is even here also. Yeah, it is power function we have discussed. This continuation will be discussed in the next class, no problem. You may study up to this problem. So we have discussed two problems today. You write, study and submit today itself, and tomorrow we will continue with these examples. Okay.